Hey there. Ever feel like everyone in tech is obsessed with like full stack everything?
Yeah.
Well, you're not wrong.
Yeah.
Full stack developers are like super in demand.
Yeah.
And today we're going to unpack why. And more importantly, give you a solid foundation for a full stack developer interview. Think of it like this. We're going to equip you to build the entire web app, from the cool stuff you see to the behind the scenes engine that makes it all work.
What's interesting is that this demand for full stack developers, it isn't just a fad. It's tied directly to how businesses operate now. As more companies rely on web applications for everything, they need people who can handle both the front-end user experience and the back-end complexity.
Okay, so to make sure we're all on the same page, let's break down what exactly full stack development is.
It's all about being able to create both the front end, which is the part of a website or app you see and interact with,
Yeah.
and the back end, which is the server-side logic and data management that powers it all. You think of it like a restaurant. The front end is the dining room, the ambiance, the menu, the waiters. It's all about the customer's experience.
Sure.
The back end is the kitchen, the chefs, the recipes, the ingredients. It's what makes the delicious food possible.
I love that analogy. And just like in a restaurant, where a good chef understands both the front and back of the house, a successful full stack developer needs to grasp both sides of the equation. We've organized this deep dive into 3 levels: beginner, intermediate, and expert. So no matter where you're at in your journey, you can follow along.
Let's start with the foundational front-end languages,
Mm.
HTML, CSS, and JavaScript. These are the building blocks of any web page you visit.
So HTML, that's the core structure of the page, right? Like setting up the different sections, headings,
Yeah.
paragraphs, all the essential elements.
Exactly. Think of HTML as the skeleton. Then CSS comes along, and it's like adding the skin, the clothes, the hairstyle. It determines how everything looks, the colors, fonts, the layout of elements on the page.
And then JavaScript is what brings it all to life. It makes things interactive, adds animations, and generally makes the web page feel dynamic and engaging. So like when you click a button and something happens, that's JavaScript doing its magic.
Right on. These 3 languages are absolutely essential for any aspiring front-end or full-stack developer. You can't build a house without a solid foundation. And you can't build a web application without a strong understanding of HTML, CSS, and JavaScript.
Now let's head to the back end where we find Node.js and NPM. What exactly is Node.js? I know it's popular, but I haven't quite wrapped my head around what it actually does.
Node.js is like a magical bridge that lets you use JavaScript, a language traditionally used for the front end, on the back end as well. This means you can use the same language for both sides of your application, which can make development smoother and more efficient.
Ah, so it's like being bilingual in the coding world. And what about NPM? How does that fit in?
NPM stands for Node Package Manager, and it's essentially a vast library of pre-built code modules that you can use in your Node.js projects. Imagine needing a specific tool for your project. Instead of building it from scratch, you can just grab it from NPM, saving yourself tons of time and effort.
So NPM is like a giant toolbox filled with ready-made solutions for all sorts of coding challenges. That sounds incredibly handy, especially for someone just starting out with full-stack development.
Absolutely. It's a game changer for developers of all skill levels.
Now, before we get too deep into the technical weeds, I think it's important to talk about version control, something that's relevant to both front-end and back-end development.
You're absolutely right. Version control systems like Git are a must-have for any developer. Imagine working on a project and accidentally deleting a crucial piece of code or introducing a bug that breaks everything. With Git, you can easily roll back to a previous version where everything worked perfectly.
That's like having a supercharged undo button for your entire project. Plus, if you're working on a team, Git allows everyone to contribute to the code base without stepping on each other's toes. It's like a well-organized collaboration space for developers.
Precisely. It's a fundamental tool for managing code, especially in a team environment. If you're going for a full-stack developer interview, you can bet they'll ask about your experience with Git.
So we've covered the basics, the front-end trifecta of HTML, CSS, and JavaScript, the back-end power of Node.js and NPM, and the indispensable Git for version control. Are you ready to move on to some slightly more challenging concepts?
Let's do it. We'll delve into the world of HTTP methods, APIs, and databases next.
All right, we've laid a solid foundation with the basics. Now let's step it up a notch and explore some intermediate level concepts that you'll definitely encounter in a full stack interview. First up, HTTP methods, specifically GET and pposty. These might sound technical, but they're really just about how web browsers talk to servers.
Think of it this way. Every time you visit a website or interact with a web app, your browser sends a request to the server, and the server sends back a response. GET and POST are two of the most common types of requests. GET is like asking a question, hey server, can I see this web page? Or can I get the data for this product?
So GET is for retrieving information. What about PST? When would you use that?
POST is for sending information to the server, often to change something, like when you fill out a form online. Your name, email address, all that data is bundled up and sent to the server using a POST request. It's also frequently used for things like creating new user accounts or submitting orders.
That makes sense. GET is for getting information. POST is for posting information. Pretty straightforward. Now, speaking of sending and receiving information, let's talk about APIs or application programming interfaces. I hear this term thrown around a lot, but I'm not entirely sure what an API actually is.
APIs are essentially the messengers of the web. They allow different applications to talk to each other and exchange information. For example, when you use a travel app to book a flight, the app uses APIs to communicate with the airline systems, checking for available flights, pricing, and booking options, all without you ever seeing the complex back-end systems at work.
So APIs are like behind-the-scenes facilitators, making sure different systems can work together smoothly. That's pretty cool. I've also heard about RESTful APIs. What makes an API RESTful?
REST, or Representational State Transfer, is a set of rules and conventions that make APIs predictable and easy to use. Think of it as a common language that different systems can understand. RESTful APIs use standard HTTP methods like GET and POST to interact with resources. And they often use a format called JSON to structure the data being exchanged.
JSON. That stands for JavaScript Object Notation Right. It's a way to represent data in a format that's both human-readable and machine-friendly.
Exactly. It's like a universal translator for web applications, making sure they can share data effectively. Now, to actually make those API calls from the front end, we use a technique called AJAX.
AJAX. That stands for Asynchronous JavaScript and XML. But I understand the XML part isn't as common anymore. So what's the essence of AJAX?
The key thing about AJAX is that it allows you to update parts of a web page without having to reload the entire page. Think about how social media feeds update with new posts without you having to refresh the page. That's AJAX in action. It makes web applications feel more dynamic and responsive.
So instead of the browser having to go back to the server and fetch the entire page again, it can just grab the specific pieces of data that have changed. That sounds much more efficient.
It is. Now let's talk about a popular tool for building web applications and APIs with Node.js, Express.js.
I've heard great things about Express.js. What makes it so special?
Express.js is a framework that provides a lot of pre-built functionality and structure for your Node.js applications. Think of it as a scaffolding. That helps you build your web app faster and more efficiently. It handles things like routing middleware and templating, so you can focus on writing the unique logic for your application.
So it's like having a set of prefabricated building blocks that you can use to construct your web application. That sounds like a real time saver.
It is. Now, you can't talk about web applications without talking about databases, the systems that store and manage all the data that makes an app work.
There are two main types of databases, right? SQL and NoSQL. Can you break down the difference between them?
SQL databases like MySQL and PostgreSQL are relational databases. Think of them as neatly organized spreadsheets with rows and columns. They're great for structured data like customer information or product catalogs, where relationships between different pieces of data are important.
And NoSQL databases are more free-form, right? They're good for handling unstructured data like social media posts or sensor data.
Right. NoSQL databases like MongoDB and Cassandra are more flexible and can handle larger volumes of data that doesn't fit neatly into a traditional table structure. They're often used in applications that require high scalability and availability.
So choosing the right database for your project really depends on the specific needs of the application. It's not a one-size-fits-all situation.
Exactly. And of course, no matter which type of database you choose, you need to make sure the data is secure. That brings us to two crucial concepts: authentication and authorization.
Okay, so authentication is about verifying the identity of a user, making sure they are who they say they are.
Right. This is typically done through usernames and passwords, social logins, or even biometric authentication.
And authorization is about determining what a user is allowed to do once they've been authenticated.
Exactly. It's about controlling access to different features or resources within the application based on the user's role or permissions. For example, a regular user might be able to view their own profile and make purchases, but only an administrator would have access to sensitive data or system settings.
Makes sense. Both authentication and authorization are absolutely essential for protecting user data and maintaining the security of a web application.
Now let's dive into some expert-level concepts.
Mhm.
That will really make you stand out in an interview.
I'm ready. Bring on the challenge. Okay, we've talked about building the front end,
Right.
managing the back end,
Uh-huh.
and securing everything.
Yeah.
But what about like when your web application starts to get really popular?
Yeah.
That's when performance and scalability become super important.
You're absolutely right. It's one thing to build an application that works for a handful of users, but it's a whole other challenge to make sure it can handle thousands or even millions of users
Yeah.
without like slowing down or crashing.
So let's talk about some strategies for optimizing performance. What are some key things developers can do to make sure their web app runs smoothly and efficiently?
On the front end, you want to make sure the web page loads quickly. That means optimizing your code, minimizing file sizes, and leveraging browser caching to store frequently used assets locally.
And what about on the back end? Are there any tricks for speeding things up there?
Definitely. Optimizing database queries is essential. Imagine searching through a giant library. If you can make the search process more efficient, you'll find what you're looking for much faster. The same principle applies to databases.
Makes sense. So we've optimized the code, streamlined the database, and now we're ready for the flood of users, right?
Well, that's where scalability comes in. As your application grows, you need to make sure it can handle the increased traffic and data load. This often involves a combination of horizontal scaling, which means adding more servers to distribute the workload, and vertical scaling, which means beefing up your existing servers with more powerful hardware.
So it's like if you're running a restaurant and it starts getting really busy, you might need to hire more cooks and waiters, horizontal scaling, and maybe even upgrade to a bigger kitchen with more ovens and stoves, vertical scaling.
Exactly. The right scaling strategy depends on the specific needs of your application and how you anticipate it growing.
Now let's talk about a more advanced front-end concept, server-side rendering, or SSR. What exactly is SSR, and why is it gaining so much traction these days?
Traditionally, web pages were rendered entirely on the server, but with the rise of JavaScript frameworks and the desire for more interactive web experiences, a lot of the rendering shifted to the client, the user's browser.
So instead of the server sending a fully formed web page, it sends a skeleton and then JavaScript running in the browser fills in the content.
Right. But this can lead to some drawbacks,
Mhm.
especially in terms of performance and SEO.
Because the page has to load, and then the JavaScript has to do its thing before the user sees the full content.
Exactly. And search engines might have trouble indexing content that's dynamically loaded by JavaScript. That's where SSR comes in.
So with SSR, we're bringing some of the rendering back to the server, sending a more complete page to the browser right from the start.
Precisely. This can improve the initial load time of the page, especially for users with slower connections. And it can also make your site more SEO friendly, since search engines can easily see the content that's already rendered on the server.
Sounds like a win-win. But I imagine there are trade-offs to consider, right? SSR probably puts more load on the server, doesn't it?
That's a good point. SSR does require more server-side processing, so it's important to weigh the benefits against the potential increase in server costs and complexity.
Okay, now let's venture into another cutting-edge architectural approach, microservices. It seems like everyone's talking about microservices these days. What's all the hype about?
Microservices are a way of structuring applications as a collection of small independent services that communicate with each other through APIs.
So instead of building a monolithic application where everything is tightly coupled, you break it down into smaller, more manageable pieces.
Exactly. Think of it like building with Lego bricks. Each brick is a self-contained unit that can be combined with others to create complex structures.
I see. So each microservice has a specific responsibility, and they can be developed, deployed, and scaled independently. That sounds like it could make development and maintenance much more efficient.
It definitely can. Microservices offer a lot of advantages in terms of flexibility, scalability, and resilience.
But it also sounds like it could add complexity, especially when you have to manage all those different services and make sure they're communicating effectively.
That's true. Microservices require a different approach to development and deployment, and they're not a silver bullet solution for every application.
Okay, before we wrap up, let's touch on GraphQL. I hear it mentioned a lot as an alternative to REST for building APIs. What's the story with GraphQL?
GraphQL is a query language for APIs. That gives clients more control over the data they request. With traditional REST APIs, you often end up overfetching or underfetching data because the server dictates what data is returned.
So it's like going to a restaurant and having to order a preset meal. You might get some things you don't want and miss out on others.
Exactly. With GraphQL, the client can specify exactly what data they need, and the server responds with only that data. This can make API calls more efficient and reduce data transfer overhead.
It sounds like a powerful tool for building flexible and efficient APIs.
It is, and it's gaining popularity rapidly, so it's definitely something worth exploring if you're interested in full-stack development.
Well, I think we've covered a lot of ground here. We've gone from the foundational front-end languages
Huh.
to advanced architectural approaches like microservices
Mhm.
and innovative API technologies like GraphQL. It's been quite a journey.
It has. And remember, this is just a starting point. The world of full-stack development is vast and constantly evolving. There's always more to learn and explore.
So for you listening, if you're preparing for a full stack interview, don't try to cram everything in at once. Focus on building a solid foundation, understand the core concepts, and then delve into the areas that spark your interest.
And most importantly, remember that full-stack development is not just about technical skills. It's about problem-solving creativity and the ability to bring ideas to life on the web.
That's it for our deep dive into the world of full stack development. We hope you found it informative and inspiring.
Good luck on your journey as a full-stack developer.